So to set a little bit of context for the first customer, we wanted to walk through the journey that Vivek illustrated, and that roadmap of understanding the business use case, and then from understanding the business use case, how we did the translation to an AI solution. The first customer I wanted to talk about was Shoob Photography. Shoob is a school photography company. So they take they are the people who go to the school and take the photo of your children and basically bring it back for all the family relative members to comment off of. What they wanted to do, the use case that they came to us with is they are already have a software that does photo correction and like photo enhancement for or when you want to make slight touch-ups to the photos that were taken, but that costs money. As every time you want to every time you want to send a photo to that photo correction software, is you're getting charged on a per photo basis. And what they wanted to do, just as like a little bit of a marketing play, was to first give people a preview as to what these enhancements could look like, and then before you end up actually having to pay for it, and then end up giving it to the photo correction software once you're satisfied with what you look like in preview. But to build that preview implementation and to have a software that would able to give them what it looks like at a preview step without having to pay money each time to show a preview of it, that's what Shoob Photography came to us for, and to see if we could build that photo correction software. And by the end of this, what ended up happening and the efficiency we brought to the solution is really a groundbreaking story. So when the first two scenarios that they deal with both background removal as well as color correction, right? And with both of these scenarios, I just wanted to talk about the background removal aspect. With background removal, we received a large volume of examples of from that previous photo correction software of the original image and then the background removed. And what we first thought we could do with the implementation is give it to Bedrock and have Bedrock come back with some of where the background coordinates existed. And then once it returned the coordinates, we would remove them through the programmatic solution that we would build and the image manipulation code that we had fleshed out. But then we saw that when giving to a general purpose model, like giving to a Claude model that's hosted in Bedrock, that doesn't really have specific context on just background removal, it was resulting in a little bit of inaccuracy when dealing with really detailed out things like hair and other those kind of features. Which is why we then pivoted the solution towards using a custom SageMaker hosted model that is purely just for the sole purpose of background removal. We took that large volume set of examples and that the customer provided and used that to then train two base models that we identified through trial and error that ended up performing the best. And that's how we ended up with what that production level solution looks like now, which achieved the accuracy that the customer was looking for. The second scenario that we had to handle was color correction. With color correction, it was a little bit of the opposite scenario where we felt that we had a set of examples of color corrected images from the customer, but this time the volume was a little bit less. And we wanted to first see what efficiency could we get with hosting a SageMaker model and trying to perform color correction through the SageMaker model. And that's when we saw that due to the less volume of examples, we didn't really get the accuracy we were looking for when just going with the SageMaker approach. But then we pivoted back towards using Bedrock to do the same coordinate-based identification and identify which pixels in the image had to be color corrected. And that's when we saw proof of accuracy, and we saw that the solution was working. But we still saw that when we started testing on various examples, we saw some where it performed really well and some where it was a little bit below the benchmark that we had in place. When we looked into each of those examples, what we realized is because there's a variation in skin tone or something like that that's being fed in the input of the image, the model is applying the same color correction regardless, right? So even if you're slightly darker skin or slightly lighter skin, the same color correction is being applied on the image, which is why we understood that, well, the approach is working, it's just that there needs to be a standardization that's in place when giving the input to the model. And so through pre-processing techniques and tweaking the prompt that we were feeding in, we sent the same image to Bedrock after it's been normalized and pre-processed, and that's when we started to see the accuracy that we were looking for from the solution. And what this effectively did is it replaced, rather than just being the software that's used for preview in the for Shoob, it ended up replacing their entire photo correction software because it was achieving that the same level of accuracy at a much cheaper cost. Brendan, do you want to add anything?
Yeah, I'll add one thing here because I think it's important. At Zeb, I'm fairly sure based on our client base, we could run this entire company and make net profit on just supply chain. And why don't we do that? Because we're very interested in these interestingly fringe use cases. When we get brought something like this, we get excited and we like to build it. And I just want to highlight that something like this doesn't fit neatly into a box. So think about that as you are ideating on use cases internally that you might want to work with Zeb on, that we get excited by these interestingly abstract use cases. So you can keep going, Zeb.
Yeah, thanks. I think that's super helpful context for the type of customers and projects my team likes to take apart.